Good morning, everyone. Welcome to another ElmLive. I hope everybody is having a good weekend. Let's see. So before we jump in, I wanted to say a brief word about those slides I had up pre-roll. Those are some posters that were published by NASA and JPL, and they're all really cool posters kind of talking about different planets that we've discovered, and they're all free for use. And I think there's places online where you can buy printed versions of these if you're interested. But these were published sometime last year. Really cool stuff. So, yes, good evening to those of you in other parts of the world than California. I guess mainly in Europe and farther east than that. So, what are we up to today? Today, I was, I guess, kind of inspired. I maybe on Twitter took a cheap shot at No Man's Sky, which is if you don't know about it, it's a space exploration game that came out in the last month, and a lot of people were disappointed by it for various reasons. But it's really an amazing game. I've been watching a few people stream it online, and basically it's a whole universe that's procedurally generated, with all different kinds of planets, aliens, and animals. So yeah, it's a really cool game. I think kind of the problem with it was the media hyped it up way more than what the developers were actually delivering. So a lot of people were disappointed with it, but it is a really cool game if you want to check it out. When I saw it, I was reminded of this really cool talk that Simon Swain gave, and I'll put the link to the YouTube video. But let me bring up here the code that he has published. So this guy, so here's the GitHub repo, Simon Swain /Deep Space. And I'll show you the demo in just a minute, but he also has a YouTube video that of a talk that he gave at JSConf Asia earlier this year or maybe last year. And his talk goes into a lot more detail, and there's a whole bunch of more demos of different kinds of simulations that he did. So it's a really cool talk. You should check that out, as well as the stuff we're going to be looking at today. So his demos are all in JavaScript, so I wanted to try to do something similar. We're not going to recreate it exactly or anything like that, but I kind of wanted to use it as inspiration and do something cool and space simulation-y in Elm. So let me show you the demo that Simon has up. So it's called Deep Space, and there's just a set of different simulations. So the first one, he has a planet, and it's simulating like population, agriculture, pollution, and industry. And in the corner, every so often, the planet builds a spaceship. So this is kind of the groundwork. Then the next one, he basically takes that planet simulation and runs multiple planets within a system. Then here in this one, when the planets launch ships, they fly around. And here, there's two planets owned by different civilizations that start fighting each other when they launch ships. And here, let's see, the next one. Oh yeah, so in this one, planets send ships out to colonize other planets and eventually take over the whole star system. And let's see, is this the last one? No, okay, this one has a star system with multiple civilizations, and they try to fight it out. And then the final one is there's multiple star systems, and there's multiple civilizations in each one, and they battle it out and eventually go and colonize other star systems. And like the root of this is all that one planet simulation that was in the very beginning of the demo. So that's kind of the inspiration. I've been realizing this is maybe a huge project. Like Simon spent, I don't know how many hours and hours building this whole thing, which is way more than we're going to spend today. I've got maybe 2.5 hours in me today. But let's see what we can do. And actually, I think a big bottleneck that we might run into is the fact that it's still a bit difficult to do graphics rendering in Elm, especially if we want to kind of render those pie charts in the planet simulation. But we'll see what we can do, and yeah, hopefully it'll be fun in any case, and at least it'll be kind of a groundwork of some more work we can do in the future if we don't get that far. So, guess let's get started. Let's see, is there anything else I wanted to mention right now? I guess that's it. I'm going to post his YouTube video in the chat for anyone that wants to bookmark that. And hey, good morning, everyone. Crits Creek is dealing with Emacs config. Well, welcome to the stream. All right, so I've already made a Git repo, and you can find it in the link in the corner of the screen. Once there's nothing pushed up there yet, but once we get this going, I'll be pushing the code up there. So let's start up Atom. Is it already open? Yes, it is. All right. And let's start up Elm Reactor. Actually, before we do that, we should run Elm Make the first time to download our initial dependencies. Then let's make our main.elm. And now let's start our Elm Reactor. And see if we can load this up. Localhost main.elm. All right, and we're ready to get started. So, where do we want to start? I guess we should start with the planet again, and I don't know that I'm going to do anything as sophisticated as Simon's example, but I want to get the basics in. And actually, if anyone has good ideas for what equations or algorithms we should use for doing a planet simulation in terms of economy or other kinds of values that we want to simulate our planet with, just feel free to make some suggestions in chat. So let's see. Why don't we start out with a planet.elm, and in traditional Elm fashion, let's think through the three things we're going to need. We're going to have a data model, we're going to have an update function, and we're going to have a view function. Although actually in this case, our view function may not go in the planet module because we're going to have different potential simulations that have different views, but all use planet under the covers. So in any case, we're going to have a planet model. I am going to call that planet in this case. And why don't we start with something simple? Let's have resources, which will be an int, and population, which will also be an int, and maybe technology level, which will be a float. Let's see, we've already got one suggestion in the chat to let each planet be a game of life board and count the living cells. That would be cool. Although I think we would probably want something a little more sophisticated, because often when you run the game of life boards, they quickly reach a steady state, or often everything dies out as well. Although maybe that's what happens on real planets. I guess we're still in the middle of the life cycle of our planet. So yeah, that does sound cool. It also sounds a little complicated, so if anyone is coding along while watching the stream and happens to implement a game of life board, put that up on GitHub and send me the link, and we can try integrating it. Alright, so we've got a basic planet. Let's also define, from the moment, a test planet. Start with, which will be a planet, and will be resources equals 10,000, let's say. Population starts at maybe 100, and technology level will start at 0. So that'll be our example planet, and I think we'll probably be getting to doing random planet generation pretty soon. So let's see. Before we start doing any simulation updates, I think the next thing I want to do is render this. So I'm actually going to make another module to represent kind of the first simulation that we're going to use, rather than doing it in the planet module, because I'm pretty sure we're going to be reusing the planet module in different simulations that we're going to build. So let's call this single planet sim. Or actually, why don't we put this in the sim folder? Alright, so then we're going to have module sim.singlePlanet, exposing the view. And I guess we're also going to have an init and an update, in which case we're also probably going to have a model. So let's go through each of these things. What's the model for this? Type alias model for this simulation is going to be a planet, which will be a planet. So we'll need to import that. So this is kind of a common pattern in Elm, where if you have a type that, oh, whoops, didn't even name this right, planet. If we have a type that has the same name as the module, it is common to import it and expose that self-named type right away. So without doing the exposing, you'd have to say planet.planet here, which is a little redundant. We already have planet twice on this line, and it's already starting to not look like a real word to me. Okay, then we're going to have our init, which will return a model. I don't think we're going to need commands in any of this, because we won't have any external events. Everything will be self-contained. And then our planet, in this case, will just be planet.testPlanet. And later, we'll want to randomly generate this when we start. All right, so how about our update section? So we're going to have a type message, and we don't have anything we need to do yet. So I'm just going to make this dummy type constructor. So in our update, we're for the moment just not going to do anything, and we'll come back to that later. Then in our view section, we're going to take our model and return HTML. And since we, okay, and we're going to return potentially our message, although at the moment we're not going to have anything interactive. But I'll just use this type since we know what it will potentially be in the future. All right, and actually, why don't we do this? Let's, for the moment, just toString our model and print it out. All right, so here's our single planet sim, or at least the template for it. So let's go back to our main and hook that up. So main is a program never, just like always. We haven't actually had a use for using flags yet on ElmLive. And this is going to be html.app beginner program, since we don't need commands. And I still have not memorized the names of all the arguments in this record. I'm just going to compile and let the compiler tell me what we need. We need a model, update, and view. Okay, so model is going to be, we've got to import this, sim.singleplanet. The model will be sim.singleplanet.init. The update will be simsingleplanet.update, and the view will be simsingleplanet.view. Let's see, so my module name is messed up for planet.elm. Oh, interesting. I renamed this later, but I think this might be because my build folder is dirty. Let's see, I'm not convinced I have a real error here. I'm going to try deleting the Elm stuff build artifacts folder first. Seems like a suspicious problem to me. Let me make this a little larger. If you delete the entire Elm stuff folder, you have to run Elm package install again to download the packages. If you just delete the build artifacts folder, you'll still have everything downloaded, but it'll essentially clean all the temporary build products. All right, so yes, that was the problem for some reason. It's like, I know there was one bug in the Elm compiler that was recently fixed that does, so the next version of Elm will track dirty dependencies a bit better, but hopefully that'll fix whatever bug we just saw as well. Okay, so in our singleplanet.elm, we forgot to import HTML. Let's go do that. And I personally tend to try to keep these in alphabetical order. All right. So hopefully that's large enough for everybody to see, but we've got our module here. Or, excuse me, we've got our model here. Let's see, so least fixed point is also making a suggestion for our simulation. They're saying, why not go with 4x defaults? Population increased by food, build stuff using production, technology increased by science. Balance those out by assigning population. Probably have different weights for different things at the planet base. Okay, I'm sold on that. Let's give it a try. So, in that case, population would be increased by food. Build uses, so there would be like building resources and food resources. Does that sound right? Technology is increased by science. Sure. Okay, so food. Let's say there's like 500 food to start with. So I'm imagining this is a planet where there's a lot of natural resources. Animals and plants are abundant, and there's a few civilized creatures, and they have no technology yet. All right. So I think our next step is to get an update loop in here, and once we have that running, we will start writing whatever simulation algorithm we want to try here. And it's probably going to go badly. It can be really hard to write a good balanced simulation. Let's see. And no, I don't think Atom has a plugin that will sort the imports. If it does, I haven't found out about it. And actually, I think there's a plugin I haven't installed yet. Let me search for this. There's this package called ElmJutsu that someone just brought to my attention this week. Here it is. Yeah, let me install this. So this is a cool Atom plugin that also does autocomplete, although the language Elm plugin does that. Yeah, but it has like go to definition, find usages, rename. Don't actually know much about it yet, but why not install it and see what happens today? All right. And they also recommend you install that I should go to Elm language plugin and turn off autocomplete. Okay, cool. I'll do that. Okay, so why don't we first write a simple function. I'm going to call this step because that's a word that makes sense to me. If anyone else has a better suggestion for this function, feel free to offer it for consideration. I'll call this step. And for the moment, let's just make this simple. And I guess have the population equal planet.population minus 1. So this will be a dying planet. But we will... this will be a dying planet, but we'll at least get our update loop working. Oh, hey Arkham. Sorry the stream is kind of laggy, or buffering. I'm wondering if I can decrease my bitrate. Let me try that when, let's see, I want to go maybe another 10 or 15 minutes and then take a break. And when we go on break, I can try lowering my bitrate for streaming and see if that makes things better on your end. I'm not doing anything like full screen graphics here. So I think I could get away with a lower bitrate. But sorry you're having problems. I will try to sort that out. All right, so we have our step function. We want to go to our single planet sim and have it use that step function in the update, which also means we want to basically have a timer that's continually running our update function. So for that, let's go look at the package documentation. Because I haven't done a timer in quite a while, but there is such a thing in the core library. And maybe it's under time. Yeah, here we go. Time.every gives us a subscription that'll fire every so often. So subscribe for the current time. This is not the greatest documentation, but it looks like the first argument is the frequency, or how many milliseconds between firing, and then we need a function that will produce a message, and then we'll get a subscription. Cool. So let's try hooking that up, and then every, let's say 200 milliseconds, let's see how that looks. We will fire an update. So this is going to go in our simulation. Oh, interesting. Actually, this needs to go in our main. So I guess we need another thing that we expose here. Subscription. So this is going to take a model and return a sub of messages. And for this, we don't really care about the model. We're just always going to subscribe. And it's saying every. So this will be in the time package. Time.every, time.second. Or no, we said we wanted we wanted every 200 milliseconds. So I guess we could just say time.second times 0.2. And then we're going to have a message. I will call it tick. And then we'll have this message. And then we'll need to handle that in our update function. Case message of. So if we get a tick, and we don't actually care about the value for now, but we could actually, and actually Simon talks about this in his YouTube talk. If you wanted to do a more accurate simulation, you could see exactly how many milliseconds have elapsed, because in JavaScript you may not get the timer callback in exact increments, but you can use the value here to see exactly how much real time has elapsed between ticks. So in this case, we're going to take the model and we are going to update the planet to be planet.step of our old planet. So that should calculate the new planet stored in our model, and we're good to go. So now, unfortunately, since we're using subscriptions, we've got to change our main program to not be a beginner program anymore, but to be a full-fledged normal program. Which means also that a bunch of these parameters are going to change. So I will use the compiler's help. First of all, in sim single planet, we did not import time. And this one we also need to expose time. Okay, great. And now in main.elm, we need, this is renamed from model to be called init, and it also needs command.none. I just happened to remember that. And subscriptions, we also need sim.singleplanet dot subscriptions, I think I called it, but I also believe I didn't export it. Or I didn't expose it. Okay, so back to singleplanet.elm. You also need to expose subscriptions. And since this is going off the line, I am going to split this to multiple lines. And let's see. expecting the program to be update. Oh, right. So our update now needs to return a command as well. So I'm actually just going to write inline here. Message model will return a tuple of calling update on the model with the message and command.none. Since I really don't want to change the single planet update function to have to return a command, because it doesn't want to return a command. So I'll let that stay the same and just deal with tacking on the command.none here at the outer level. Hey, all right. So that is working. So we've got the timer ticking and it's running our update, and our population is slowly dying. Although I think it's going to go negative in a second. I'm not sure what that means in our simulation. Is that like zombies or something? Well, anyway, let's go ahead and commit this, and I'll push this up. So to start out, we are going to git ignore our Elm stuff folder. And I think everything else is good to add. Basic framework for a planet simulation. Cool. So let me push that up. How come it's not dying? They're not dying that slowly. That's 5 people per second are dying. That is quite a lot if there's only 500 people on the planet. And let's see. Chris Creek was saying maybe you can have the update function accept a time delta and use request animation frame. I believe. Oh, okay. I was thinking time.every actually used request animation frame. But according to this note, apparently it does not. Need something based on request animation. Okay. There definitely is a function in core that lets us do that, but I am blanking on what it is off the top of my head. So if anyone remembers, feel free to remind me in the chat and we can swap to using that. But also, I think for the purpose of today, I'm just going to run 1 tick every time there's a new frame, because I'm not really worried about having this play smoothly, since there's no interaction here. Cool. So this was a pretty short segment, but actually I want to take a quick break here, mainly because I need to refill my water, but also for Arkham I want to try reconfiguring my stream bitrate. So I'm going to pause the stream for just a minute, or I'll put the break screen up for a minute, get some water, and then I'll come back and try to adjust the stream, and then we will continue.